We like to think we understand the solar system. We have the maps, we have the probe pictures, and we have the textbook definitions that make everything feel safe and orderly. But when you look past the familiar comfort of Mars or the predictable giant that is Jupiter, you hit a boundary. You reach a place where the rules of physics don't just change, they start to feel like a personal insult. We aren't just going to look at a planet today, we're going to step into a true cosmic abyss. Welcome to Neptune, the loneliest and quite possibly the deadliest place in the solar system. Look, let's get one thing straight. This isn't just another gas giant. It's not just a slightly colder version of Saturn. Neptune is an outlier, a cosmic oddity that challenges every assumption we have about how planets are supposed to behave. When we sent a probe like Voyager 2 out that far, a journey that took 12 agonizing years, the data that came back didn't just inform us, it shocked us to the core. This is a world where, if you dropped an ice cube, it wouldn't melt. It would become a permanent geological feature of a world that is effectively a frozen hell. We talk a lot about Mars or Jupiter, but Neptune is where physics goes to have a nightmare. It's a place of supersonic winds and diamond rain. And today, we're going to find out why reaching this blue giant is a one-way ticket to the most beautiful execution you can imagine. It's easy to focus on the red dust of Mars because we can almost imagine standing there in a suit. We can visualize the swirling storms of Jupiter because they are colorful and iconic. But Neptune is a dark, vibrant, menacing mystery. It's a place that forces us to redefine what a planet can actually be. We're talking about an ice giant, a world composed of a superheated, slushy mix of water, ammonia, and methane that scientists casually refer to as an ocean. But trust me, this isn't an ocean you could ever swim in. It's a highly pressurized, electrically conductive substance that covers a solid, rocky core. Getting to that ground means passing through an environment designed by nature to disintegrate you in ways you didn't even know were possible. Let's sit with the feeling of isolation for a minute, because it's not just a statistic on a Wikipedia page. When you are on Neptune, you are on the definitive edge of our planetary neighborhood. You are so far out, so radically cut off from the warmth and light of the inner solar system, that our concepts of time, space, and even human connection begin to evaporate. You are, quite literally, beyond help. Let's talk about the lonely part first. Neptune is so far out that it takes 165 years just to complete one orbit around the Sun. Since we discovered it in 1846, it's only finished one Neptunian year. Think about that. Entire empires on Earth have risen and fallen, and Neptune hasn't even done a full lap yet. Think about the sheer, staggering scale of that time gap. In 1846, the telegraph was the absolute pinnacle of human communication. We hadn't even fought the Civil War. The Industrial Revolution was just getting its legs. Since then, humans have invented cars, planes, computers, the internet, and AI. We've fought global wars and put boots on the moon. And through all that noise, all that history we are so proud of, Neptune was just silently, slowly, coldly making one single, lonely trip around the Sun. To Neptune, the entire modern history of humanity was just a particularly long Tuesday. When time operates on that scale, our lives seem less like a story and more like a brief, insignificant flicker in the dark. And it's not just the time, it's the view. The psychological effect of that kind of distance would be shattering. From Neptune, if your eyes could even perceive it, Earth is not a pale blue dot. It is absolutely nothing. If you were standing there, well, floating there, looking back at Earth, you wouldn't even see a pale blue dot. You'd see nothing. You are effectively cut off from the rest of the neighborhood. It's just you, The dark and a cold so deep it actually slows down time at a molecular level. The inverse square law of light is a brutal ruler in the outer solar system. The sunlight that reaches Neptune is 900 times fainter than what we get on Earth. If you were floating in that azure abyss, the sun wouldn't look like a majestic disk giving life. It would be a particularly sharp, distant, and uncaring star. Radio signals, which travel at the speed of light, take over 4 hours to go just one way. If you sent a message saying, "Heater broke, help," you would be frozen solid for 4 hours before anyone on Earth even heard you scream. The true terrifying scale of isolation isn't just the miles. It's the absolute, unbridgeable delay in human connection. You are trapped on the other side of an 8-hour round-trip wall. But okay, let's say you solved the heating problem. You have your supersuit, your plasma shields, and you can handle the isolation. You're fine, right? Wrong. The planet isn't done with you. The real nightmare of Neptune isn't the cold or the distance. It's the sheer explosive violence of its weather. You thought Jupiter had bad storms. You think the Great Red Spot is scary. Jupiter is a wind tunnel simulation. Neptune is the real deal, operating at Mach speeds you can barely comprehend. Now let's get to the deadly part. You might think Jupiter has bad storms, but Neptune makes Jupiter look like a summer breeze. We're talking about winds that clock in at 200 miles per hour. That's faster than the speed of sound. If you stood in that wind, you wouldn't just be blown away, you'd be disintegrated. This is where the physics nightmare really kicks in. On Jupiter, the winds max out around 400 miles per hour. Fast? Sure. But on Neptune, they average 700 miles per hour and can peak at 200 miles per hour. That is Mach 1.6. This happens not because Neptune is hot and dynamic, but because it is too cold. There is no internal heat to generate complexity, so the fluid dynamics are exceptionally efficient. With zero friction or thermal complexity to slow them down, the winds just keep accelerating, faster and faster, turning the planet's atmosphere into a terrifying supersonic engine. If you were even partially exposed to that wind, you wouldn't be blown around. The sheer forces alone would rip your molecules apart before your brain could even process the pain. And then, just to be sure you are dead, there's the rain. And then, there's the rain. Deep inside Neptune, the pressure is so intense that it crushes carbon atoms into literal diamonds. It sounds beautiful, right? A sky raining diamonds? But these aren't small earrings. These are massive chunks of crystallized carbon falling through a high-pressure slush at terminal velocity. It's a diamond hailstorm that would crush a titanium tank like a soda can. The chemistry here is brutal. Neptune's atmosphere is rich in methane. As you descend, the pressure grows to millions of times the atmospheric pressure of Earth. This intense crushing force literally breaks the methane molecule apart, releasing the carbon. Under that pressure, the carbon doesn't become graphite. It is immediately crushed into diamond. These diamonds, which can be massive chunks, then begin a slow, highly pressurized descent through the slushy mantle. This isn't a beautiful spectacle. It's a terrifying diamond hailstorm falling through a dense medium. If one of these hits your spaceship, it wouldn't just bounce off. It would act like a cosmic artillery shell, flattening a titanium hull as if it were a cheap soda can. But the deadliest part of Neptune isn't just the environment, it's the way it treats its neighbors. Neptune is not a friendly neighbor. It is a cosmic kidnapper. And its biggest moon, Triton, is a tragic testimony to Neptune's dominant, destructive nature. Neptune isn't just lonely, it's a cosmic kidnapper. Its biggest moon, Triton, is a weirdo. It orbits backward. Why? Because it's likely a captured object from the Kuiper belt that Neptune just snatched out of space. But here's the tragic part. Neptune is slowly killing it. Triton is unique because it has a retrograde orbit. It travels in the opposite direction of Neptune's own rotation. This backward motion is proof that Triton wasn't formed here. It was a captured dwarf planet, something like Pluto, that strayed too close to Neptune's gravitational well and was snatched out of the Kuiper Belt. It's a beautiful icy museum of cryovolcanoes, but it is also a captured hostage. And Neptune is not going to release it. In a few 100 million years, Neptune's gravity will rip Triton apart, turning that beautiful moon into a ring of icy debris. It's a slow-motion execution happening right before our eyes. Neptune is the king of its domain, but it destroys everything it touches. Every single lap Triton makes, it loses energy and drifts just a tiny bit closer to the Roche limit, the point where the planet's tidal forces become stronger than the moon's own gravity. When Triton crosses that line, it's not going to crash. It's going to simply dissolve. Neptune's powerful gravity will pull on one side of Triton harder than the other, shredding the captured moon molecule by molecule. It will turn Triton's ice fields into a magnificent icy ring structure. It's a tragic, slow-motion ending, proving that Neptune's dominion is ultimately a graveyard. So, why does this dark, frozen monster matter to us? It matters because we have effectively ignored it. Why does this matter to us? Because Voyager 2 is the only visitor we've ever sent there. One brief flyby in 1989, and that was it. We've ignored this blue monster for decades, but as we look at other star systems, we're finding that mini-Neptunes are the most common planets in the galaxy. This is the real cosmic tragedy. We have sent dozens of probes to Mars. We have orbiters around Jupiter and Saturn. But Neptune has been visited exactly once. We haven't sent an orbiter back. We don't have detailed maps of its surface dynamics. We have effectively left the King of Isolation completely alone for decades. Yet, as we look at the exoplanets orbiting distant stars, we are finding that planets the size of Neptune are the most common type of planet in the entire Milky Way. We are ignoring the archetype of our own galaxy. So if we want to understand the universe, we have to understand the most extreme, isolated version of it. Neptune isn't just a planet. It's a reminder that the universe doesn't care about our comfort. It's cold, it's violent, and it's hauntingly beautiful. Neptune reminds us that our cozy, warm world is the exception. The universe is indifferent and violently extreme. Neptune is the definition of that extreme. It is cold that slows down time, wind that defies the speed of sound, and a kidnapper that executes its own moons. Understanding Neptune means accepting that the standard definition of reality stops too, 8 billion miles out. It is a terrifying nightmare, but it is also a magnificent work of physics. And that is why we have to go back. Thanks for watching, and I'll see you in the next one.